Welcome to video 8.9, Graphs of Linear Inequalities. This is going to count as your video check. This would normally be a skill tech type thing. Identify the slope and the y-intercepts of each of these equations. Please write this on your homework that you're submitting and put it in a box that says video with the label video check. Thank you. Draw a box around it, I should say. This is the handout that I handed to you in class. If you don't have it, you can find it on Schoology under handouts. This is for notes for linear inequalities. Please take a moment, copy this down, and I will be glad to go over it with you in just a second. Okay, ladies and gentlemen, you're going to be solving for y. You're graphing using the slope and the y-intercepts. You're going to use solid lines or dashed lines. If it's greater than and equal, less than and equal, or just simply equal, you get a solid line. If it is less than or greater than, as these two, you're going to get a dashed line. This is an example of a dashed line. A solid line would be one complete line. Also, shading. You need to shade based on what your answer is. So if you're getting a greater than or greater than equal to, you shade up. If it's less than or less than and equal to, you would shade below. So here's an example where they have you solving. Remember that when you're doing this, if you are dividing by a negative, then you're going to be, or you multiply by a negative as well, but in this case we're dividing by a negative, then you need to flip your inequality sign from a less than to a greater than. And then you need to go back and check. Also, on the next slide, you're going to find out what Hoy and Vux is. It helps you keep some things straight. So let's go ahead and go. In your notes, you're going to want to write Hoy and Vux. Hoy is horizontal lines. That is, when the slope is 0, you have y equals. So when you have a horizontal line, your slope is 0, and it's for the y equals. So when you see y equals 5, you know you're going to have a horizontal line with 0. That's your slope. If you have a vertical line, you know it's undefined, and x equals 0. So for Vux, it's a vertical line up and down, it's undefined, and it's x equals 0. And if we think about the rise and the run, you'll see why we have a slope of 0 and a slope of undefined. So for horizontal, if I have the horizontal, I'm going to have my rise over my run. That gives me my rise. So if I have a horizontal line, am I going up any? No. But am I going left and right? I am. So that can vary from whatever that number is. So that can be some value. I'm just going to put a number sign. For my vertical line, if I go to see what that looks like, my rise is going up, so it's some number. But I have no run. I'm not going left or right, so that's 0. Any fraction with a 0 in the bottom we call undefined. So that's when I see x equals something. I know I have a vertical line and it's undefined. Take a moment to write that down. When working with linear inequalities, I'm going to find a variety of solutions that make the statement true. But there are also ones that will not make the statement true. So my job is always to test it to see, is this going to be true if I put in these ordered pairs? So in this case, I have 2x is minus 3y is going to be less than 6. So I'm going to substitute 0 in for x. And what I should end up with should make sense when I put 1 in for y. If this is a true ordered pair, that makes a true statement. So 2x minus 3y is less than 6, putting 0 in for x, 1 in for y, I get 2 times 0 is nothing, or 0, minus 3 times 1 is negative 3, is less than 6, that is negative 3, in fact, less than 6, it is. So we know that one is a true statement. So now I'm going, oh, I'm not quite sure what's going on with my slide here. Hold on a second. Okay, I made a quick correction so that way we're not being driven crazy by those little blue things. So we're going to check for another set of ordered pairs for that same inequality. So if I have negative 2x minus 3y is less than 6, I'm going to substitute these ordered pairs in. Wherever I see x, I'm putting 4. Wherever I see y, I substitute a negative 2. So I end up with 2 times 4 minus 3 times negative 2. Will that be less than 6? Well, 2 times 4 is 8. and negative 3 and negative 2 is positive 6. 8 plus 6 is 14. 14 is not less than 6, so this is not a solution. There is a second part to this video, so make sure that you watch the second part as well and come with questions that you might have.